All right, cappuccino assassino, everybody. Welcome back. We are, I don't know. Zeke gets in trouble for it because he hears it. Yeah,
That's
like,
loud.
not kidding. He's at the point now where it's, I'm mad, and like you can tell his voice is quivering because he's about to start crying when we tell him not to do something. And it's okay, dude, go be mad in your room. I'm mad. And I'm his bully. All right, here we are. This problem, whether we finish it or not, what do we know all three angles in any triangle will always add up to? 180. Notice, I have how many of the angles on this right side triangle? I have 3 total, and I know 2 of them. 57 plus 59 plus x better be 180. Okay, now to formally do this problem out, that's exactly what we'd write. We would say x, just kidding, okay. We would say x plus 57 plus 59 equals 180. Now, for this, I am hopeful that everybody in here could take a couple steps and solve this. Do you want to see the mental math approach, how I solve it? Okay. Do you have to be good at mental math in my class ever? No. The better you are with just simple stuff, the easier and faster stuff will go. Do you guys agree that 3 times 60 is 180?
Yes.
Okay. This is how many short? If these were all 60, this would have to be 60. But this is how many short of 60? So I'm now at 63 for that other angle. This one is how many short of 60?
1.
So add one more. I think it's 64. Like, that's how I do that mental math. If you would rather combine them, I'm cool with that. I'm just going to put dot, 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 x equals 64. Okay, the second I get it, I'm going to write in here 64 degrees. What's this angle?
6.
Why?
These are vertical.
Andrew, you said wait. Go ahead.
I thought it was 74.
Why?
Yep, I think x is 64.
I got x equals 70.
So let's see, this is x plus 116 equals 180. Do you have that written?
No.
So I can see your scratch work.
'Cause I remember I had you look at it before we went to the weekend.
So I definitely looked at this and I like this, but I don't think 57 plus 59, this is what I didn't check, it's not 106, it's 116. That's the only thing that happened. So you were just off by 10, which I didn't notice it. Just a little mistake, easy to fix. Okay, if that's 64, how on earth do we get y?
42 plus 64.
So 42 plus 64 plus y better be what?
180.
Is also 180. And let's just quick math, that's 106
Yeah.
equals 180. Whoa, 106 plus y equals 180, and y must be 74. Okay. Interior angle sum theorem. Feel okay? All right. Now, if we talk about the interior angles, and that's all fine and dandy, what other types of angles might there be? There probably are some exterior angles. So 2.11 was the triangle angle sum theorem, and we didn't specify, but it was really truly focused on the interior angles. Today, you will have time in class to work on stuff, so don't sweat it, but we do get a new theorem. Last theorem of the section, we are going to get a ton of time. So theorem 2 point, lost my spot, still lost my spot. Theorem 2.12. The triangle exterior angle theorem. And it feels redundant to say theorem 212 at the triangle exterior angle theorem. I don't know. All right. When we draw our exterior triangles, we're going to sneak in a little bit of vocab. Are we in a metropolitan area, or would you say that here in Unalaska we are remote?
Remote.
Now, you guys have heard remote before in that context, I think. If somebody says I'm from remote Alaska, they might mean here, but they might mean somewhere else. What do they mean when they say remote?
Outside of normal.
Outside, removed maybe, like from everything else, right? Okay, so here's the deal. We're all going to begin by sketching a single triangle. And I don't care what it's called, but there's a couple different approaches. I'm going to actually draw 2 of them. You don't need 2 of them. I just want to show you the 2 different ways that you could think about this. Okay. In this theorem, I could make 180 degrees out of these three, 100%. That's the last curve that we saw. Are there any exterior angles right here?
Yes.
Did I draw them?
No.
Not yet. So when you're drawing the exterior angles, there's a few ways we can do it. If we want all of them, what I do is I just follow one line. And do you guys agree I'm going, like if I start at this point and then go to this point, and then I could go from this point to this point, so I'm going around in this order every time. Okay, so why I'm focusing on that direction is if I take this bottom line, I could extend it out, and I could make a now exterior angle. Everybody see that?
Yes.
Could I extend this one up as well and make an exterior angle up here? And I could do it the third time, and I get these three exterior angles. Now, we don't really need all of them, but I just want to show like, hey, we could draw all three of them consistently like this. Instead of going from the bottom left to right, could I have gone right to left and drawn this exterior angle instead? And then I'll just keep that same process through, and I could draw those three exterior angles here. I can do it consistently through so that I'm always going from this point to the next, and then from that point to the next, so forth and so on. Okay, in either of these pictures, it doesn't really matter. You don't need two of them. I'm going to label some angles. 1, 2, 3, and then we'll call this 4, 5, and 6. And I'm going to get rid of my second triangle. This one was just to show you like, hey, we could draw them either way. Okay. So in the triangle that we have on the board, the first thing that I care about is I've named three angles on that triangle that I would consider to be the exteriors. What are the three angles that are exterior on that triangle?
4, 5, and 6.
Lily claims 4, 5, and 6. Do you all agree with that? Okay, so if we do a little bit of logic here, what do you guarantee that 1 and 2 and 3 add up to?
180.
1, 2, and 3. Andrew, are you okay with that?
Yeah.
These all add up to 180. Okay, what's 2 plus 4 have to be?
180.
So check this out, just logically, and we're essentially setting up the proof. Everybody is square with these three having to add up to 180. And these two add up to 180. So if 1 plus these two is the same thing as 2 plus these angles and 2 plus that angle 4, they both add up to 180. What do you think angle 4 has to be equal to?
I understand what you're trying to say,
Yep.
but I'm very confused with
Nope.
what you just said.
Nope, that's okay. We're not proving it yet. We're going to write it down. We'll write some stuff. I'm going to claim the following. Here's our actual theorem. Given a triangle, any exterior angle is equal to the sum of its remote, I'm going to sneak in a vocab here, remote interior angles. Now, we have a ton of them that we can look at, and we're going to make sense of what this is actually saying. Given any triangle, the exterior angle is the sum of its two remote interiors. Now, we get a bunch of opportunity to write this here. Let's pick any of our exterior angles, and we'll just do the EG here using this picture. So here's our actual proof at work. Which exterior angle do we want to think about? So I'm just going to start with angle 4 is exterior. That's the if part. Do we all agree that angle 4 is an exterior angle? Okay. If angle 4 is exterior, and it is, then we're going to be able to say something about the measure of this angle. Now, at the start of this a minute ago, we talked about remote Alaska. I like the idea of we're just removed from the rest of Alaska. Is there an interior angle that's really close to angle 4? Angle 2, that's nearby. What are the remote angles then? The ones that aren't near angle 4, that are on the inside.
1 and 3.
These ones are far away from 4, right? That's a remote location, like distance between them. What this theorem is telling us is that if we have an exterior angle, we do, then the measure of angle 4 is simply those other two remote interiors, which are measure of angle 1 and 3, added up. Now, what I was saying before, which it's hard to talk the math, and that's my bad, I will try not to do that. These have to add up to 180, and these have to add up to 180. So if we pretend like if this was 60 degrees right now, angle 2. This would have to be 120, right? And these two, if this is still 60, would also have to add up to 120, so we get to be the sum of 180. That's it. That's our whole proof. If we wanted another one, and you don't need to write it, but I want to make sure. Andrew, with confidence, can you tell me what measure of angle 6 is equal to? And I'm going to leave this one here. What is the measure of angle 6 the sum of? What are the two remote interiors?
2 and 3.
Good. Measure of angle 2 plus the measure of angle 3. Love it. Vincent, what is the measure of angle 5 guaranteed to be equal to in this picture? Here's 5. So you said 1. That's one of the remote interiors. I agree. Measure of angle 1 plus what's the other interior angle that's not neighbors with 5? 6. Is this on the inside of my triangle? 2. 2. 3 is the neighbor. 2 is the remote one. Okay. Every time this will work. Now, we are going to do a weird split today. We're going to do like, I don't know, 1 or 2 problems. Should we prove this real quick? Yes, answer a question first. Could you prove this?
Yes.
Walk me through it. Like, we're going to logic proof it, okay? Let's sneak in a number here. What do you want to call this angle? Don't scribble on yours.
Or 2.
So give me like an angle. Or we can just call it 2. Wait, let's just call it 2. We're going to think through the proof, okay? What do you know 1 plus 2 plus 3 is? Okay. Now, that's the interior angle sum, right? Okay. Beyond that, what do you know that measure of angle 2 plus 4 is?
180.
So that's also true. If these are both 180, could we just set them equal? Measure of angle 1 plus the measure of angle 2 plus measure of angle 3, gross, equals the measure of angle 2 plus the measure of angle 4. Why am I allowed to write that? And what's the justification? Boom. Okay, last little step. Camille, what could you take away from both sides of this? So we could take away 2. There's that one. I am goofed up. Why am I goofed up? 1 and 2 and 3. Oh, no, we're good. What's the measure of angle 4 then? Measure of angle 1 plus 3? Because that's the only thing that's left over here. And check it out. We didn't justify, but we're completely proven. That is always true. Carson, you can go. You're going to miss, not math, but you're going to miss a little something. You can go to the restroom. You're good. All right. Very different vibe from that comment than I think you aimed for. But that's okay. Here we go. On the following. You guys are going to have like 10 minutes today to start homework today, just so you know. I want you to find for me, find missing angle. And it'll be very clear which one it is. Here we go. On A, we get this lovely triangle right here. There it is. That crazy guy. And on this crazy triangle, I'm going to give you that this very bottom left angle is 45 degrees right here. And then I will mark this one not to show it's congruent to anything, but just to mark it. Let's say that that is 75 degrees. I want you to find me angle 1 right here. And rather than just saying you find it for me, I want somebody to help me find it. Now, there's a few different ways that we can do this. 2 ways we can do this. You can use either the interior angle theorem, or you can use the exterior angle theorem. Either one works. If we're using interior, what do these 3 have to add up to?
180.
So we could find this angle, whatever it is, and then we could say this angle plus this angle must be 180 as well, and we could plug it in and find it. Or, if Carson could tell us, from here, what are the 2 remote interior angles?
45 and 75.
Here are my remote interior angles right here. And according to that last theorem, I know that this exterior angle, its measure, written as the measure of angle 1, is just the sum of these 2. So whatever 75 degrees plus 45 degrees is going to be our answer. What is 75 plus 45? Are you sure?
Yes.
What's 75 plus 5?
80.
Add 40 more?
120.
Cool. Baller. Super hard. Okay. One more for me, just so I can feel a little bit better. And then we're done. Oh, I like this one. Okay, for this problem, this time we have this first line going. And we're going to have another triangle formed, and we get this lovely line. I'm going to say there's x and y. There's what we're after. And all that I know about this lovely figure is that the bottom left angle, we're told, is 48 degrees, and the top angle up here is 77 degrees. And I'll make that a little bit more clear. 77 degrees up here. I'm going to pause this and let you guys work through it. I want you to find me x and y. Notice that we have two different exterior angles given. That's okay. I'll give you a moment. Chat with me, chat with your neighbor. I'm going to figure out your homework while you're chatting. Go. I'm going to take every single assignment that I give you until we get a consistent turn-in rate. Okay, so today we finished the triangle angle sum, and we'll just specify we did exterior. And you guys get homework 2.3. You will find homework 2.3 waiting for you on page 91. And I want you guys to do problems 12. Ooh, love it. 15. And then let's see here. 18 through 27. Okay. Tomorrow, when you wake up in the morning and you're considering your wardrobe for the day, I would encourage you, whatever algebra pants you have, wear them. Cool.
Wait, no odds?
I mean, there's lots of odds in there.
Not 18 to 27.
Yeah, no.
I mean, you can do the odds, but as long as you do the evens. Yeah, it's like 5 problems, dude. We're cool. Sweet. All right, you guys do it to it. Get started so that I feel the desire to give you these extra questions again, or extra time rather.